Welcome to the video on the last part of 13-2, which is the unit circle. The goal of today is going to be to still evaluate trig functions, but this time using something called the unit circle. So as a review of what we did in the last video, I'd like for you to find the tangent of 405. Okay, so as of this moment, how would we do this? Well, first, we have to graph it. So we want to put the standard position of 405 degrees. Now, 405 degrees is bigger than 360. So we know that it's going to make one full rotation. Now, how much further does it travel? Well, we have to subtract 360 from that to get 45. And so we're going to travel an additional 45 degrees. Okay, so that leaves us in quadrant 1. Now, we know in quadrant 1, the reference angle for our standard position angle is exactly the one that we see. Okay, so there's no additional calculation. The reference angle will be 45. Okay, so that means tangent of 405 is going to be equivalent to the tangent of 45, and we just have to pay attention to our signs. So what are our signs? Well, we know all students take calc. We are in quadrant 1 where all trig functions are positive. So that means that the tangent of 405 is going to be equivalent to the positive tangent of 45. So we do not need a negative sign there. So next, we need to reference our special right triangles because it is one of those 3 special angles. So this is the 45, 45, 90 right triangle. Okay. We know that that has the side lengths of 1, 1, and radical 2 because that's something we would memorize. And the tangent is opposite 1 over adjacent. So this is equal to 1 over 1. So the tangent of 405 is equal to 1. Okay, so now today we're going to be calculating the same values, except this time we're going to be using something called the unit circle. So what's the basics of our unit circle? Well, a unit circle is just a circle with radius 1. Okay, so if I drew this on a coordinate plane and we drew a circle, we would have the circle that intersects the x-axis at 1, 0 and negative 1, 0, and the y-axis at 0, 1 and 0, negative 1. Every other point on this circle also has a radius of 1. So now, why is this radius of 1 so important? Well, let's review our trig functions. Sine of theta, cosine of theta. In one of the other videos, we talked about how to find the sine and cosine based off of the ordered pairs, x, y, and the radius r. Sine was equal to y over r, and cosine was equal to x over r. But on the unit circle, r is equal to 1. So when I put these two values over 1, what we're really saying here is that when we are on the unit circle, my cosine of theta is going to be equal to x. And my sine of theta is going to be equal to y. Okay, so that's what's so special. We don't have to calculate the radius anymore. It just makes it so that the sine and cosine are equal to an x or a y value. Which means anytime we say we're on the unit circle, any ordered pair that we are given will immediately give us the calculations for sine and cosine. We just go to our x value as cosine and our y value as sine. Okay, so that's the part of the unit circle that is so useful. All right, is that sine is equal to y, cosine is equal to x. So now, we do need one other vocabulary word, and it's the quadrantal angles. Okay, these are the special angles that fall on an axis, okay? So for the most part, we've only talked about what happens in quadrant 1, quadrant 2, quadrant 3, quadrant 4. But we're ignoring these angles that represent the quadrants themselves. So those would be 0, 90, 180, and 270, okay? So 0 would just be basically the positive x-axis with no degrees. 90 degrees is having the positive y, positive x. 180 is that straight line. And 270 is positive x, negative y. So what is so important about this? Well, these ones are going to have easy trig calculations when we are on the unit circle. Okay, so again, when we are on the unit circle, x comma y is really cosine comma sine. So if we're looking at the angle 0, and we have a radius in this case of 1, we know we're going to hit this axis at 1 comma 0. So what does that mean about sine of 0 and cosine of 0? Well, sine is equal to my y, and cosine is equal to 1. All right? And if you notice, as we go through the rest of them, they're all going to be some combination of 0, 1, and negative 1. So let's take a look at 90. Right? Let's say r is our radius. So this would intersect at 0, comma 1. So what is my sine of 90 degrees? Well, that's equal to my y value, which in this case is 1. What is my cosine of 90 degrees? Well, it's equal to my x value, which is 0. Let's take a look at 180. We would intersect the x-axis at negative 1, comma 0. So my sine of 180 is going to be equal to my y value, which is 0. And cosine of 180 is going to be equal to negative 1. And last but not least, 270. We have 0, comma negative 1 as the point we would intersect on the unit circle. So that means my sine is going to be of 270 is going to be equal to negative 1. And my cosine of 270 is going to be equal to 0. Okay, so these are special angles that have special calculations. Okay, they're all a combination of 1, 0, or negative 1 when we are on the unit circle. Okay, now if you want to find 360, remember we just continue rotating. 360 is equal to 0. So we're back at this quadrant angle there. Okay, so now what about the rest of the points? They're not all going to be perfect 1s and 0s. So let's take a look at the main angles you will see on a unit circle. Okay, so the unit circle, we already said, has a radius of 1, but they tend to show the points of all of these special angles in all the quadrants, meaning all the angles that have reference angles that are 30, 60, or 45. Okay, so now it is our job to find out what the ordered pairs will be for these particular angles. Okay, so we're going to do quadrant 1 first. Right, we already talked about how 0 degrees is 1 and 0, okay, and 90 degrees is 0, comma 1. So let's take a look. Well, if this is cosine, comma sine, okay, if we use our special right triangles, we can find the x and y values from it. So the side opposite 30 is 1, radical 3 and 2, and for the 45, 45, 90, we have 1, 1, radical 2. Okay, so let's start with 30. My x value is cosine. So cosine of 30 is equal to adjacent over hypotenuse. So the x value right here is going to be equal to that amount. My sine of 30 is equal to 1 over 2. So that value is going to be my y value. Okay, and we can continue. 45. We want the cosine of 45. Well, cosine of 45 is equal to 1 over radical 2. When we rationalize, we get that that's radical 2 over 2. So that's going to be my x value because that's my cosine. Now, if we remember, when we have the 45, 45, 90 right triangles, the sine and the cosine are going to be equivalent. So this is going to be also radical 2 over 2. And now let's do 60. Cosine of 60 is opposite over hypotenuse. So my x value is going to be that. Sine, not opposite, that was adjacent over hypotenuse, of 60 is equal to opposite. I apologize. Let's redo that for a second. Cosine is adjacent over hypotenuse. So adjacent is 1 over 2. And sine is opposite over hypotenuse, which will be radical 3 over 2. Okay, so we've done our first quadrant. Now, if you notice, the way that the unit circle is set up is that the angles closest to the middle will be all the angles with reference angles that are 30. All the middle ones will be ones with reference angles that are 45. And all the last ones will be ones with reference angles that are 60. Okay, so if we think about all students take calc, we don't have to do these calculations again. We just have to pay attention to what will be positive and what will be negative. So let's take a look at 150. 150 is a reference angle of 30. In this quadrant, sine is positive and cosine is negative, which means we're going to have the exact same values, but my x value of cosine is going to be negative. My sine will stay positive because of the quadrant. 45, same thing, same values, but a negative x for negative cosine. 120 has a reference angle of 60. Negative cosine, positive sine. So I'm going to ask that you pause the video and fill out the bottom half. See if you can figure it out. Okay? And let's check our work for that. Okay? So this is a fully completed unit circle in degrees. Okay, notice those are the only values we need. The signs just flip. So make sure you check your work on this. Okay. So the last thing we need to talk about that we've been neglecting is the tangent. How do we find the tangent when we're on the unit circle? Well, since we know on the unit circle y is equal to sine and x is equal to cosine, and since we also know tangent is equal to y over x, that means tangent of an angle is going to be equal to sine over cosine. So if we are given a point on the unit circle, we can just do a simple calculation to find the tangent. For instance, tangent of 30. My sine is my y value. My cosine is my x value. Keep, change, and flip. We will get these two things canceled out. And we have to rationalize to get radical 3 over 3. Please attempt the following two